Hello everyone, welcome to Explorer Hop. Let's solve part A. Solve 6x minus 2 is greater than 10, which can be written as 6x is greater than 10 plus 12. This would give us 6x is greater than 12, therefore x is greater than 2 is our answer, which can be written down as x is greater than 2 at whenever x is equals to goes from 5 goes from 2 to infinity. That's our final answer. And you can combine it with this as well. So x is greater than 2. So let's solve minus 15x plus 2 is greater than minus 28. This becomes minus 15x is greater than minus 28 minus 2. So what is minus 28 minus 2? Minus 28 minus 2 gives us minus 30. Therefore, minus 15x is greater than minus 30. We can take 15 down here. Remember, whenever we, in an inequality, whenever we divide by a negative number, our inequality sign changes direction. So this becomes x is greater than minus 30 over minus 15. Therefore, x is greater than positive 2. Since negative and negative make it a positive. So therefore, x is greater than 2. And we can also write this down. So the solution for this equation is x is equals to 2 to infinity. That's our answer for this. Now that we have part B as well, let's move on to part C. So part C looks a bit more difficult and complicated, but I can assure you it's not that difficult. We can just initially solve this like a regular inequality. Let's move 2x squared to this side. This gives us 2x cubed minus 2x squared minus 12x is greater than or equal to 0. Now that we have that, we can factor out 2x, which gives us x squared minus x minus 6 is greater than or equal to 0. So now that we've gotten that, we can write this, we can factor this thing out on its own. So which would give us 2x times x minus 3 times x plus 2 is greater than or equal to 0. Now we can equate them, all three of them equal to 0 and solve for x. So for this one, x is equals to 0, x is equals to 3, and x is equals to minus 2. So therefore our zeros are, the x-intercepts are x is equals to 0, comma 3, comma minus 2. Now let's plug these on a number line. So a number line, we'd say 0 is here. We get 1, 2, 3, 4, minus 1, minus 2, minus 3. Okay, so let's mark down our zeros. So one of our zeros is at 0, one of our zeros is at 3, and one of our zeros is at minus 1. Sorry, minus 2 actually. Minus 2. This is a minus 2. Okay, now that we have that, Now basically we're trying to figure out where this equation is greater than or equal to 0. So we use test numbers. When x is less than -2, this 0, which is this way, we can use the number -3. So therefore we can plug this into our equation right here. This would give me 2 times -3 times -3 minus 3 times -3 plus 2, which is equals to -6 times -6 times -1, which is a negative number. Therefore, it is negative on this side. So when we go towards less than -2, we get less than 0. Now let's test out -1, which is between -2 and 0. So we get 2 times -1 times -1 minus 3 times -1 plus 2, which is equals to -2 times -4 times +1, which is a positive number. So therefore this is positive, and this is greater than or equal to 0, so this is correct. Now we need to take a number between 0 and 3. I can choose any number I want. Just for convenience, I'll choose 1 and substitute this into our equation, this equation. So 2 times 1 to 1 minus 3, 1 plus 2 gives me 2 times -2 times 3 gives me a negative number. Therefore this area is negative as well. So this is not true, this can't be included. Now let's see if it's less than or greater than 0 whenever x is greater than 3. So we'll take the number 4 and test it out. So 2 times 4 times 4 minus 3 times 4 plus 2 gives me 8 times 1 times 6, which is a positive number. So I'll mark it positive here. This is correct as well. Therefore, the two intervals that are correct are from -2 to 0, which is positive, and whenever x is greater than 3. So therefore, our answer is from -2 to 0, which is this interval, which I marked here, and the other one is greater than 3. So union 3, comma, infinity. And that's our solution. Thank you for joining us. I hope to see you in the next lesson.